The displacement of a particle starting from rest at t is equal to 0 is given by s is equal to 6t square minus t cube. Time when the particle will attain zero velocity again. Okay, so now when their question says again, it basically means that the body was at rest and then the velocity was zero. So once again, when would that velocity be zero is the question asked here. Okay, so very straightforward question. So what is given in the question? S is equal to 6t square minus t cube. What is velocity is equal to? Is rate of change of s, which is basically equal to d by dt of 6t square minus d by dt of t cube, which is v is equal to 12t minus 3t square. Now if v is equal to 0, right, that is what the question asks about. What would be the time in seconds at which the particle will attain zero velocity again. Now if v is equal to 0, we can say that 12t minus 3t square is equal to 0, right? In which case, if we take 3 common, or if we take 3t common, what do we get here? 3t into 4t minus t. Okay, sorry. If I take my bad, if I take 3t common, what do we get? Is 4 minus t is equal to 0. Now see, we have two different points to be noted here. One is that you can't cancel out t square and t by equating 12t is equal to 3t square, because then the number of roots will become 1 because you cancel off t from both sides, right? Because the question very clearly says that second time when will it happen, which means that it is happening for two times, and then it should be noted from our end that we need two values. Second, when a into b is equal to 0, either a should be equal to 0 or b should be equal to 0, in which case either 3t is equal to 0 or 4 minus t equal to 0. This is the first case given the question, the body was at rest, and the second case would be at t is equal to 4 seconds. Let me just explain the point once again. See, what I was about to say was that if 12t minus 3t square is equal to 0, if you take this equation as 12t is equal to 3t square, then you say that if 4t is equal to, sorry, if then you say that it is 4 is equal to t, essentially what you're doing is you are reducing the number of solutions to 1. Because what can happen is this question can be framed in other way also. How many times can the velocity become zero with respect to this relation? If such a question is asked, if you approach this solution, what will happen is you will say that it will reach velocity only once, which is wrong. Because if you solve the equation by preserving the quadratic equation, what happens is you will get two values, which means the velocity becomes zero twice. So that's the difference here. So always keep this in mind that whenever such a question is asked, make sure not to reduce the number of roots. So that's it with this question. Let us now move on to the next question.